Happy Monday, everyone. My name is Ryan Kelly. I'm the General Manager of AMT's San Francisco Tech Lab. And I'm here today to host another episode of Leading Today. So lucky to be joined by Anna-Katrina Shedletsky. Anna is the CEO and co-founder of Instrumental. I think some people have heard of Instrumental, but everyone needs to be familiar with them. So Anna, let's just start at the beginning. What is Instrumental, and why does a company like this need to exist today?
Awesome. Well, thanks for the introduction. I'm really happy to be here. So my name is Anna Shedletsky. I'm CEO and founder of Instrumental. Almost exactly 6 years ago today, even, I was an engineer at Apple. I was leading product design for the first generation Apple Watch before, I guess people knew there was a watch, but it hadn't shipped yet. We were in PVT, the final validation build, before starting mass production. It had been such a complex product that the launch date had been delayed several times. And I'd been back and forth between the US and China multiple times in the previous 18 months because being on the line when it was running, trying to be in the right place at the right time, was the only way we knew how to proactively find issues that would bite us later if we rolled into production without finding them. So Instrumental helps our customers solve that one key problem. It's too hard to find and fix issues on manufacturing lines. We're not just talking about the failures you know about. We also means the ones that you don't, that cause fallout, rework delays, and returns in your process that you might not be anticipating. 20 cents of every dollar spent in electronics manufacturing is wasted because of this problem. And Instrumental is a manufacturing optimization platform. We help our customers to collect product data from their supply chains, leverage smart, no-code tools to discover issues, do virtual failure analysis, and make connections between cause and effect. Our customers are the largest, most admired electronics brands in the industry. And I brought along a video to show what we do a bit more tangibly. So let's roll that as an introduction to Instrumental.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich remote data set to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today.
I'm glad that we started with that video, because I think that we heard in your sort of initial description, right, of like some of the pain that you experienced when you were an engineer at Apple, which a lot of people see as one of the absolute leaders in the manufacturing and supply chain space. But
they still are.
Right. And this is actually the point that I want to raise, is that even the world's leading manufacturing supply chain companies, the solution to a lot of their problems is manual. It's being there in person. It's looking over people's shoulders. It's carrying around a clipboard. This solution seems extremely relevant to what's happening in the world today. And so I think that, this is one reason that we really wanted to have you on, is to sort of to talk about this. But where I want to dive a little bit deeper is to say, this isn't just a remote workforce type solution. This isn't a solution that says you don't need to go to the factory all the time and look over people's shoulders to look at defects. It's actually quite a bit more sophisticated than that in terms of what it enables. It's not just a facsimile for being there. It's more. Can you dive into a little bit more detail? Why is this better? Obviously, having a remote solution to not have to go to the factory, especially if it's overseas, is an advantage. But the solution provides a lot more than that. Maybe you can expand on that a little bit.
Yeah, absolutely. So I think one of the things when people first started hearing about Instrumental, when we were first getting started, one of the benefits was to potentially reduce travel. But really what we're about is trying to figure out how to solve problems and to take the types of problems that engineers solve every day and create a software that amplifies your ability to solve those problems quickly. So yeah, being in the factory is a slow way of solving problems. So we want to accelerate and amplify that particular piece of it. But like another slow way of solving problems is having to physically tear down 20 different units and look inside and see what the issues are inside to try to do failure analysis. So that's like an example of something that we accelerate through technology, so you don't have to physically rip apart 20 units. You can just look at the photos of those images of the units as they were built up. Another place that's really slow is that oftentimes our customers are collecting all sorts of functional test data on the line, but that data is siloed in the local stations, or maybe they have some of it that gets into an MES, but it's in the electronics industry. It's not very common that the brand has access to the contract manufacturer's MES system. And so there's always this kind of back and forth over emails, spreadsheets, trying to get the data from multiple sources, and data cleaning that happens to even just get something where you could like put it into make a scatter plot to see if there's a relationship between two variables. And so we solved that problem by just enabling our customers to hook it into an API. So it's very easy to have your image data, your functional test data all together in real time. And then when you go in there to actually solve a problem, you identify like, oh, we have, our zero insertion force connectors are like not getting closed properly, and they're going to come and wiggle out, and that's going to cause failures. You can actually immediately set up a test for that in Instrumental and then push that live to the line wherever your line is, anywhere around the world. And you don't need to know anything about like how the software is working. You just need to know the things that you know already as a mechanical engineer trying to design products. You need to know what's broken, what does good look like this is something you care about, and that's the expertise that you bring. And we try to take everything else out that is like not that expertise. So mechanical engineers shouldn't be doing data cleaning. They shouldn't be wrangling across spreadsheets and emails. I used to get these spreadsheets from the factory, like Excel spreadsheets that had like little tiny photos in each cell, and you had to like drag each quarter out to see each photo in the failure analysis report. Like, we don't have time for that. So really, Instrumental's taken the perspective of like, what are all the steps in the process from discovering a problem to solving it, and how can we accelerate and amplify what our customers do at every stage of that process? And can we use software to make it faster? And can we use machine learning and other kinds of advanced techniques to actually do things for our customers or make suggestions, so they're not like having to brute force everything?
Yeah, and it sounds like, one of the things that you're saying is the difference of data reporting being a chore or a part of a contractual agreement. Like, okay, here's the data you asked for. It's in this maybe not super easy to consume format, and actually turning it immediately into something that is useful and actionable.
And a distinct competitive advantage frankly, for both sides of that commercial agreement. Like, it's a competitive advantage for the brand, who's like able to find issues earlier, able to move faster time to market, lower like yield hit like when they start production. And it's great for the factory too, because a lot of times the factory bears the brunt of the finger pointing for anything that goes wrong in the early days before people figure out like what the root cause is. And by eliminating that finger pointing, the factory is able to be most supportive on the things that it's really great at, which is building and transforming products from pieces into products. So we see it as win-win all the way around, which is pretty great.
Tell us a little bit about the data collection process. Data is central to Instrumental, and also the sort of the what both sides in terms of the manufacturer and the brand and the different teams within them are looking at. What sort of data goes into that stream, and how is it being collected?
Yeah, so maybe actually if we can show slide 8, that might help to just kind of put a picture to, as I described, kind of where that data comes from. So while we work on bringing slide 8 up. So essentially we pull data from multiple sources. That's the whole point, is that the data is right now pretty siloed. And so if we can aggregate that into one place, it can be really powerful. So the first thing that we can do is we can actually deploy equipment onto lines that can take images, photographic data, key states of assembly. So this is not like typical industrial cameras where you use, one camera, one issue kind of paradigm. It's an array of cameras that are positioned at key states of assembly where you can see a lot all in one view. And so we have drop-in equipment for that. If you already have industrial cameras in those locations, we can take those images too. That gets funneled up. We also pull data from what we call functional test stations. So if, we're in the electronics industry, so our customers are testing antennas, speaker, Wi-Fi, microphone, all of these tests that are on the line. This test station data is usually the parametric data, like the details of the test, like what was the frequency response at 10 kilohertz, is important information that can help an engineer actually solve a problem versus just the pass-fail information. A lot of time the pass-fail information will go into the MES system, and that's what will be reported in daily Pareto charts, but it doesn't tell you like, are these near passes? They almost passed and they're like, there's something small, or are there multiple failure modes? But you can see that if you have the actual parametric test data, where you can have all the details for each of the tests. So we actually pull data using APIs from those sources, and those could be anywhere in the supply chain. So we have customers who have they're capturing photographs from multiple physical factories in multiple different locations, sometimes even countries. They have test station data coming from upstream suppliers, their final assembly testing packing facility. We actually have customers who are also pulling test station data from returns and refurb, where they're using that kind of field failure analysis of like, okay, this product was returned for this complaint. What specification, like how could we measure that complaint in terms of our specifications? And should we then go change our specifications upstream to not ship products that are like in that range, particularly for new products where you haven't been shipping them for many years. So you don't know if your specs are good for a good customer experience. So that's where we're pulling data from. We pull that into a managed cloud. It's secure. And then our customers are able to log in and actually manipulate the data from anywhere in the world. The data is real time. It's flowing in real time. They can make changes to that data and actually push tests in real time back to the line that can run in real time. So really trying to close this loop between understanding what issues are and actually being able to take action on them is where Instrumental focuses. And because I come from the space, you don't have a lot of time when you're an engineer like me. So like, you don't have a lot of time. You don't have a lot of you don't have time to spend integrating something. You don't have time to spend learning something. So this is a for us, by us kind of tool where it's really like engineers design this the way that they would want it to be. There is no integration to get started. You can drop this thing in, and in 12 hours, you're getting data that's valuable. You can set up tests. You don't have to know anything about machine learning to like use machine learning. That's kind of it's seated in the background. You use your engineering expertise to essentially get the maximum out of the tool.
Yeah, and I've got more questions related to the by us for us aspect of the product, but tell us a little bit about when you're inspecting, how many of the products coming off the line are getting inspected? Is this like doing some kind of statistical sampling, or is it different than that?
No, so we do 100% inspection, and we advocate to our customers that the best way to get maximum value is 100% inspection, because some combination of like Murphy's Law or whatever it is, if you're sampling, you're not going to see the things that are going wrong. And instrumental, we scoop way down into a Pareto of issues. So like typically you might be working on 1 or 2 issues at the top of your Pareto, like couple biggest yield hitters. But instrumental is able to work on hundreds, 150, 200 issues at a time. And so we scoop really far down into the 0.2, 0.1% level issues, and all of that area, like all of that is value for our customers. And you can't be sensitive to 0.1, 0.2 issues if you're not looking at everything. Now, in some types of manufacturing, that may sound like crazy talk, like, oh, well, I'm not building smartphones. I don't need to look at everything. I'm not building millions. I'm building 50,000 a month. But even at that scale, depending on how expensive your products are, like you want to be looking at everything. If you don't measure it, it must not matter. But yet it does matter. Like every single unit matters. It's yield fallout, it's yield hit, it's wasted materials, it's like slowness in your supply chain. And so that's why we advocate for 100%. So usually test stations are 100% to begin with and are usually not sampling. And so we try to fit into our customers' process where we're able to capture 100% without slowing them down. And that's very important, that they don't have to make a trade-off on throughput in order to get the data on everything.
Yeah, and that's actually the idea I was driving at here, which is not only can you capture 100%, but you recommend it. And that also you sort of like espouse of the benefits of doing exactly that. But I think a lot of people that are in this industry don't even know that this type of thing, being able to capture hundreds of data points on every single product at different points of the manufacturing assembly process, is even possible. So that was the point that I wanted to just really make clear.
And you can do it without slowing your line down. So there's not like a trade-off. Like a lot of times people are like, okay, of course we could inspect everything, but we don't have days, right? And I think the point is that there are solutions that exist that can inspect everything without slowing you down from how you're already building. And so if it was free from a time perspective, would you do it? Absolutely, because the benefits are obvious if there wasn't a trade-off. And I think that previously there has been trade-offs to doing that.
Sure. And so let's now get back to the for product engineers, by product engineers. Now that this tool is available, how are the people that are using this technology, how has it changed their lives, and how does it set them apart from their competitors who aren't doing things this way?
Yeah, so maybe I can share by talking about a couple specific examples. It's really, I founded this company with my co-founder because manufacturing really needs to level up, and there's really no longer excuses for why it hasn't yet. Our customers care about the same things that everybody who manufactures does. So time to market, yield, margins, brand perception in the field, happy customers, competitiveness. They care about all those same things. What's interesting about instrumental is for a given customer, the impact is actually a little bit different because products are different, companies are different, the things they value are different. And so I'll share like 3 quick examples of a couple of different ways our customers get value from instrumental. So we work on a lot of smartphones. That is a thing that we do. So high volume, relatively high value products. We're regularly saving those customers hundreds of thousands of dollars in their development process because they're able to accelerate faster. They're able to prevent mistakes that would be costly in production. We are de-risking their programs so they're able to be more likely to hit their shipment dates, which of course is a top line number because a delay is actually impacts how many peak days of sales you have, particularly in competitive markets like smartphones. And in this industry, cost savings of a cent per unit is considered like a good idea, like a big deal. We're saving them regularly $1 in production. So the orders of magnitude above kind of conventional cost savings techniques. So there's lots of real like financial value for a product like this in that particular use case. We have a lot of customers, smartphones and not, who are based in the US and they build in Asia. And this past year, they haven't been able to travel. So engineers have used Instrumental to be able to remotely understand what's going on, identify issues, do failure analysis, make corrective actions from thousands of miles away. And 100% of our customers shipped their products this past year during a time when EMS supply reported that 53% of programs were actually delayed or canceled. So these customers view Instrumental as an absolute need to have and do not plan to go back to massive amounts of travel once travel restrictions are lifted. Not because it's about replacing travel, but because they find that they can be more effective and more impactful using it than even if they were able to travel. Although I love travel, and I think it's really important from a building manufacturing relationships and team building to travel to your factories. But I think traveling to a factory to stand on the line for 8 or 10 hours a day, which is what I used to do, trying to be in the right place at the right time is not good. It's not good use of time.
It doesn't need to be an either or.
Yeah,
you don't want to necessarily rely on that.
But use the time efficiently. I mean, we have customers who use Instrumental when they could travel, and they found that they would use it even when they were in the factory to know what was going on in different places in the factory, so they'd know like where they want to go. Any of the factories I worked in, you had to get through a metal detector to get on the line. It took 15 minutes to get onto the line. So you want to make sure you're going to the right place where you're going to be impactful. The last, sorry, go ahead.
No. I was just going to say, I mean, it seems like in that, like using that way of thinking about it, it gives you sort of an additional sense, or even like a superpower that says, well, this is what I should be looking at today as a side of just being there and kind of intuiting what sort of looks like what I need to focus my attention on right now.
Absolutely. I mean, software engineers have had telemetry for a decade, if not more. I'm not a software engineer, but like for a really long time, they could tell which servers were up, which ones were down, which ones were having issues. Like, oh, we have an issue. Where is it? Like, they have that data. Like, you talk to a sysadmin or someone and you're like, oh, you can't have like telemetry on what's happening in your server farm, and they like don't know what to do. So this concept that we operate that way, building something very complex in the physical space, and we don't have good telemetry on even like what's going on, where the units are it's a quality good, that we don't have real-time metrics on that is kind of crazy. So we're really just kind of catching up. It's not even superpowers at this point. We're just trying to get powers. Basic powers.
Yeah, and that's actually, it all sounds very futuristic and too good to be true. What we've talked about so far is that it's not. It's here. It works. Ready to be used. It works. But one thing that we've talked about before is sort of the frustrating reality that when these solutions come along in these industries that are more traditional and slow to adopt new technologies, the pitch, despite the overwhelming evidence that says this is really going to help your company, it is sometimes difficult. Can you tell us a little bit about that? Particularly being the founder of this company, a practitioner that saw the need, that built a company, is showing results, and yet every factory in the world still isn't using that. Why is that? What are those struggles like? And sort of how do you navigate those challenges? And how would you, sort of what lessons learned can you share for other entrepreneurs that are looking at this industry saying, I can provide a compelling solution, but I know that this is a tough road?
Is a tough road. So we actually don't sell to manufacturers. That's one. We actually sell into the brand part of the ecosystem, and happy to talk about that a little bit more. But to your point around, how to sell new technology into industries like manufacturing. So certainly manufacturing has a reputation for being slow. But I actually think the industry is not slow. It just has high standards. The industry really wants products that have short or no integrations, that do what they say they will do, and provide strong ROI. It's pretty simple. And I think that products that do this, people, once they've tried them, they see that this will work, and they will adopt those technologies. And that adoption can be pretty quick, quicker than people think it should be, given how slow manufacturing is. Not to gripe, but I personally believe that GE did a lot of damage to the manufacturing technology space when they let their Industry 4.0 marketing kind of get out ahead of where the products were, and inadvertently kind of cast a chill on the industry. I think for nearly a decade, everyone that we talk to has a story about how they piloted like a industrial IoT or Industry 4.0 solution, and it just totally failed and face planted. And so every executive has that failure experience of like, we believed in the pitch and it didn't work, so why would it be different this time? Oh, and you're not even GE, because GE is like a big known brand. And I think this is just starting to thaw now. Like in the last couple of years, we've certainly seen a thawing on more openness to reconsidering technologies that might have been sold to them, 5 years ago and didn't work. And I think COVID has really broken it wide open, because pain is real, and people need aspirin now. So besides a lot of broken trust for the technology, I think Instrumental has a unique product that no one's Googling for. So that's another issue for other entrepreneurs or other leaders who are building manufacturing technologies. The major challenge is really around educating customers. Our customers know it's too hard to find and fix issues. They've been working around it for decades, and that's the problem, that they've been working around it for decades. So it's kind of ingrained as a cost of doing business, and they don't think about it much. So it's our job and how we approach our market to bring this problem to the forefront and demonstrate there's a solution. But like, we're happy in a conversation with a customer if they leave just thinking about the problem as a problem that might actually have a solution, whether it's Instrumental or not. We think it should be us, but whether it's us or not, that's each one of those conversations is pushing the overall industry towards addressing some of these large wasteful bits that we've had for a really long time.
What would you sort of advise, not just early stage companies, but all companies, to address the very high standards that this industry has? What do you see as maybe where some of these companies are falling short, and what must they do to be able to say we're good enough?
You mean what must like new technology companies do to be good enough for?
That's right.
Low integration, no integrations, low integration cost, very fast time to value, I think is incredibly important in an industry. So like the approach we've taken, when you buy a piece of equipment in manufacturing, it takes like weeks to like deliver and weeks to set up. And that's like kind of the experience that people have. And they're also very used to buying equipment, like a capital expenditure. And so for better or worse, Instrumental's approach has been to kind of shake up how people perceive these technologies by fundamentally shifting some of the things that they think are kind of ingrained as rules of like how it must be to interact. So when our customers buy Instrumental, they don't buy the hardware. Like that's a foreign concept to them. They're like, wait, what? We don't have to pay for this? So like we're already different. When they work with Instrumental, they essentially sign on the line. They will have data within 4 weeks, sometimes faster. Contractually, we'll usually sign up for 4 weeks, but if we can go faster, we do. We help customers in emergencies. So we've signed papers on Friday and had data flowing in on Monday. So we've built the solution to have very little integration. And we built a go-to-market around having little integration, because the customers we sell to don't have time. They're already overwhelmed. They already have too much other complexity happening. It's already too hard. And so we've really tried to be very thoughtful about how could we make this easy for someone who has too much to do, to be able to get to a part where they're able to get value I think having really short time to value is also very important. It makes you want to have a magic moment for a customer as early as possible in the process. And that's where you move from something that's like, okay, this is nice to have, it like kind of works, to like actual people loving your product and thinking that they can't live without or design without your product. So those are some of the things that we've been focused on in designing the approach as a go-to-market for instrumental. There are probably many other approaches that work for different subsections of the market. We are in the electronics vertical. It has a certain culture. It has a certain way of operating. That doesn't mean that this would work well for medical devices, or frankly, automotive, I think would require something totally different. And I'm not an expert in that space, so I don't even want to pontificate, but like all these different verticals kind of require different approaches. And we devised our approach after, like, with great empathy towards the customer and our own experiences of what would we want to buy.
Right. Now, with a solution like Instrumental, that it's got a big purview, if you will, in terms of it might be in different manufacturing sites, and within your customer, it's going to be touched by a lot of different departments. Who do you talk to? Where does the conversation start? And who ultimately champions the decision to use Instrumental? Is it like C-suite? Is it below? Is it a combination of those things? I'm just trying to wrap my head around it a little bit. And also, for the people that might either want to become a customer or want to tell their boss that they should really consider this, how do those conversations normally go with a product like this that a lot of people touch and benefits a lot of different departments?
So we've sold it every which way. So it's possible to do every which way. I would say our most common first interaction with a customer is usually around a development program that's like about to start or has just recently started. So in electronics, like we have this EVT, DVT, PVT kind of different build stages. We're usually trying to hit so that we can start at EVT. So we're usually talking, 6 weeks, 8 weeks before the EVT date to potentially support that program. We can be brought in by engineers. We often do get brought in by engineers. Usually the champion inside a customer tends to be like the project lead on the engineering side. So, a product design lead, a mechanical engineering lead for the program, or their, I guess, supervisor manager who might be a director or VP of engineering. That's usually where we'll start. And that sale is fast. It tends to be no brainer. It tends to be like do I believe that having additional data on every unit in development will help me find and fix issues faster? Yes. Okay. How much is that worth to me? Like, well, I can think about my travel budget. I can think about what is the cost of delay? And like Instrumental costs so much less than that it's a no-brainer purchase of like, even if this thing helps us on one issue, it probably pays for itself. And so that's usually how we start. We have started in production directly, but usually we use the data with our customer, working with our customer from development to actually pitch it and its particular specific value for that specific product in production, because production is very much ROI driven. You save us this many cents and you cost us this many cents, and it has to make sense financially. And so you can't make a general claim that like, oh, for any product we will save you X cents. You can't, because it's very product specific. And so we use that data from development, working with the development team to actually identify where and how Instrumental can be most impactful in production to allow for continuous improvement and kind of monitoring in production. The value proposition is a little bit different in production. And so that's typically how we sell. We're typically operating at like director VP level. Usually in production, you end up having to go up VP level-ish in general, because that's where those kinds of expenditure decisions are made, because it's fundamentally a bit different than how they have typically built. However, like it's on the line in development, so it's been validated and qualified as part of the development process. So it's not like trying to shove something in at the last minute for a production line, which generally doesn't work well. We have done that for customers who've been in pain, Like there was a specific in production, specific ongoing issue, line was down, production was stopped, whatever it is, and they need help solving a specific problem. And so we're always happy to like be helpful in those emergency situations, prove our value, and then continue to work with that customer to expand across the rest of their product line. So that's typically how we interact. We have come in with innovation leaders. We find best that what works best though is a combination of having high level buy-in that like we need to level up and that savings is worth it, and alignment across, improving the quality or improving our time to market or our competitiveness or our customer experience, whatever the value system of the customer is, that you have high level buy-in that this is something, the company's trying to do this. And then you need the low level buy-in of the individual engineers who are actually going to use it. And they will only use it if it actually improves their personal like workflows. And so we've kind of tried to build the product so you can have a top-down buy-in, bottoms-up usage to really get the value. So we sometimes come in from the bottoms up as a result. We sometimes come in from the top down at like C-suite level. Like this is something we think we need to accelerate. Like we have too much risk on this program, or this isn't, we have a product. We worked with a customer who had a product they'd been shipping for 5 years. It's a mission critical product. It must work. It cannot fail in the field. And then shipping it for a long time, and they'd had ongoing yield issues. So they had tests to make sure they weren't shipping bad ones, but they had a lot of fallout. They had to do a lot of rework, and they hadn't been able to root cause why the rework rate was so high. And they had done all of the best practices things you can do, so many different kind of Kaizen processes, lean manufacturing processes, try to improve this yield fallout problem. And really, they bought Instrumental. We got 250 units worth of data. So like not even that much data, like a couple of days worth. And just having that data come in and be side by side, those engineers were able to identify and kind of essentially make months of progress in like hours in that first day of seeing that data, to eliminate potential root causes in their long list and really push them in the direction of where it was coming from. In this case, it was some very complicated combination of like cavities of multiple parts plus some process issue. So it was a very intractable problem where many things were compounding, but the failure rate was high. So it was a big business problem.
And when they came across the root cause of this problem, finally, using the solution, what was their feedback? I mean, were they surprised? Were they overjoyed? Were they immediately looking at a solution? Like, I just think that for looking at something for so long and not being able to see that solution, like what?
The engineers were delighted that they didn't spend months doing something that they were able to achieve in, several hours. They were like, this is great. And so they were sold on the value in their particular workflows. And then the executives were very excited because, they have more than one program. And there's value. They started to see like the vision of value across everything they do. If they had better understanding of everything they were doing, what could that possibly mean for the bottom line, for the business, for being competitive in the space? Because they're not the only player. So like, again, bottoms up and tops down buy-in for different pieces of it. Because, at the high level, they care about competitiveness and margin. And at the lower level, they care about getting the job done and building a great quality product that they feel good about going home every day. So yeah, that's kind of how we approach it.
It makes me think about this phenomenon where when you look at the same problem over and over and over again for like an extended period of time, it just sort of becomes part of your reality.
Yeah.
And the statistic that you mentioned earlier, which is, 20% or, 20 cents on every dollar is sort of lost. And in this case, electronics industry is probably different in other industries, but that's a really, really high number. And I wonder
that's actually the conservative side of the number, as an FYI.
So is something like this at play here, where we're really that 20% number is there as a result of people just saying about the problems that they experience on a daily, yearly, multi-year basis?
It's the 20 some people have told us Bain thinks it's as high as 40. But they're incentivized to think it's that high. So Bain Consulting Group. But automotive industry executives would say 35% is kind of the number we get. So we've picked 20 because we feel it's very defensible, but it's probably higher. And where it comes from, it's mistakes during development where you like cut tools and they interfere. Like it's the normal stuff you find in development, mistakes. It's experiments and design of experiments, DOEs, that people are running during development to solve problems because it's the only way they can figure out how to solve them because they can't quite root cause them, so they have to be experimental. It's scrap, rework, all of that. Not just at final assembly, it's all the scrap all the way up the supply chain. And so for electronics products, there are many parts in those supply chains. So the supply chains are big, and there's often different requirements in terms of things like cosmetics or stuff like that that cause scrap all the way up the supply chain. It's travel, it's wasted kind of human time. So that could be downtime where you have a whole line of operators twiddling their thumbs for a day because you're not running anything. That could cost you $20,000 that one day. There are some factories where the line goes down. It's $1 million a day because there's so many lines. So like this is where all that comes from. And so Instrumental exists because we're working to attack that. Like, how do you solve that? Like, that's a huge amount of waste. And it's so rare to be able to work on a business where what's good for the world, like in terms of sustainability, efficiency, waste, is also like really good for the businesses that are like having those problems. There's like this small overlap, and we're like right in the middle where our customers don't want to waste more stuff because it's expensive. It's also not good for the world, but it's also expensive. And so if there's an opportunity to really chip away at that, so we've got our eye on that. We think that the core problem, or one of the core problems, is just that it's too hard to find and fix issues in development, even do continuous improvement in production. It's too hard, it's too slow. And so therefore we kind of aggregate this waste across these programs. And if we were able to be a little bit more proactive or a little bit more connected, we're able to operate faster, shorten cycles that take weeks into hours, then we'll be able to start to recoup and not waste both the physical waste and the electric waste and energy waste and human time waste, as well as the monetary waste associated with those mistakes.
Yeah, I had sort of come to that same thought as you were talking about it. I mean, so it's a big trend right now for large corporations, especially, to be very focused on this concept of sustainability and environmentally friendly. And there's new standards and large scale projects that are going on. You read about them in the news sometimes, about people's efforts to make sure that people's supply chains are sustainable and ethical.
Yeah.
And it seems like what you're talking about, like when you're looking at this huge fraction of waste that has its downstream effects, that not a lot of people look at that as potentially a source for dealing with the sustainability issue. But certainly from a resource perspective, it seems like that could really be the case. And so that I agree with you. That's a very cool way to deal with that, seemingly on an oblique way, but actually possibly the most direct way to deal with sustainability is by dealing where the biggest amount of waste actually is. Maybe just in jet fuel alone, potentially, that has like a monument.
Yeah, well, like there's just a quick comment on that, because we have a few customers that this is something that they've publicly talked about as being like, they have like sustainability initiatives. It's part of what they're kind of in their public brand are chasing after. One of the things that was really interesting, I was talking to one of these leaders who's leading one of these initiatives, and he said, well, the most expensive, like environmentally expensive part in an electronic device is the printed circuit board, and everything involved in the printed circuit board, the parts that go on it, the chemicals used, all that stuff. That's like very expensive. And so, his thought was like, well, we're just going to try to make our circuit boards as small as possible. And that's how we're going to like reduce our carbon footprint. And I was like, why don't you just not throw out like 20% of them?
Yeah, exactly.
in like a part. Maybe the printed circuit boards, like the yield on those parts tends to be very high. So like goodness in the world for, automated SMA, SMT lines, great. But like then you put it in a phone and the speaker doesn't work on the phone. And when you rip the circuit board out, like you break it, well, that's like now you're throwing away, percentage of that circuit board. Now there's all the other parts too. I'm sure batteries have like pretty intense footprints. Jet fuel, like you say, like all of that stuff. So I think we haven't, it's just something that's kind of in our thoughts as like an organization. It's really about efficiency. And I think efficiency is great for everybody. Like, cause nobody wants to do stuff that's wasting. Wasting money, wasting energy.
I don't think I've ever heard the sort of the engineer's argument for efficiency is better at all costs mapped to it's also, maybe also greener. But I think that there's a strong,
tiny little spot,
strong case to be made, and that can have a big impact. All right, I'm going to switch directions entirely. Your background is not in software engineering, as you mentioned, and now you helm a software company. Tell us a little bit about what that's been like, and sort of what are the things that you've learned along the way.
Yeah, I mean, the first thing I had to learn how to do was how to hire software engineers. Like in the most practical case, there was lots of learning to do. I'm also a first-time founder, so I grew up as an engineer at Apple. So I have some experience. Obviously, Apple is not everyone's experience, acknowledging that, but it's a very admired company for execution for a reason. So I feel like it was a great place to grow up. And so some of the things we've had to tackle, like not so much ingest, that was literally the first one we had to tackle, but less ingest. One of the things we're kind of tackling right now is, or just in general of building a company in this space, is where people get their information from. So something that's kind of interesting, it's kind of ironic that we're talking about it here at IMTS. Like one of the most surprising things that I've learned is that executives, at least in the electronics industry, whether they're engineering or manufacturing executives, I thought there was a place they might go and like learn stuff. Like, is there some secret Reddit that like they're talking about that like I'm just not invited to, or like is there some underground Quora, or is there some like event they all go to? And we ask people all the time, because we're trying to build a company in here. We're like trying to figure out like, well, how do we like find people who have these problems? We are told most often that they find out best practices on new technologies or just new best practices in one-on-one conversations with either their coworkers or their former coworkers. And so it's like a backwards regressing kind of like flow of information. And some of them obviously come to IMTS and events like this, but a lot of them don't. Mm-hmm. And so we find that kind of mind-boggling. And I think that the fact that there aren't like communities and places where best practices, I think electronics is kind of funky in that we have this whole consumer electronics part of it where there's a lot of secrecy. And so that might be part of it that's just kind of snipped all the connections between people because they're so worried about secrets, they don't talk about stuff. But I think it slows down the entire industry as a result of not having constant dialogue. Like there's no place you can go online and even as an engineer, if you want to ask a question about like HF8600, which is very common glue, like, hey, like what are the ways I'm going to get screwed if I pick HF8600 over, some other type of glue with glass beads in it. Like there is a lot of expertise out there on exactly that topic, and nobody is talking about it. And then you talk about like at the executive level of like, hey, what technologies actually work and which ones don't? And like that would be a great question to like have a discussion about. And it's one-on-one conversation. So we're really excited to partner with organizations like AMT, IMTS, to try to create opportunities for those conversations. Frank practical, tactical conversations to take place, because I think that's been really surprising piece that I didn't realize would need to be part of building a company, is building the community around the company as well.
Well, that's a great tee up for us to discuss Build Better, which is a second annual event that and actually AMT has been involved in this event for 2 years now, as a sponsor. And this is, I guess,
this is our answer.
The answer to that. We start to create community around that. And I can attest to, actually being physically present at the physical Build Better, which happened last year, that it was exciting to actually bring a lot of practitioners and solution providers together to discuss exactly this. You could tell that they were hungry for it. It was also one of the last in-person events that probably everybody got to come to before COVID. So maybe tell us a little bit more about the Build Better 2021. What the programming is going to be. Obviously, it's not going to be held in person, but yeah, elaborate a little bit on what our viewers, who I'm sure are excited to now know that there can be more of this conversation being held as soon as next week.
Yeah. So Build Better is the annual manufacturing optimization summit. It's for executives who formerly only learned best practices in one-on-one conversations with their coworkers or former coworkers and their personal private networks. This is our second year, as you mentioned. It will be all virtual. We have over 550 executives from electronics, medical devices, and automotive have already signed up. It's next Tuesday, so if you're interested, it's free. You can sign up. We have a great lineup of speakers talking about real issues and real tactics. That's really what we're trying to. This isn't really a selling event. There is a separate area for selling. This is really about what are the things that executives need to know about either emergent manufacturing technologies, remote development. That's a reality this year in 2021. It's not going to, COVID pandemic and travel is not going to be open in time for NPI, new product introduction season this spring. So talking about misaligned incentives within their organizations and changes they might be able to make to actually align incentives better so that operations and engineering teams are all rowing in the same direction. We have a great speaker who's going to talk about how to quickly, like for executives who have no time, how to quickly identify and evaluate AI solutions when you aren't an AI expert. Like, what's the cheat sheet? Like, what's the 3 questions I need to ask, and like, what answers do I need to get before I even, okay, maybe this is worthwhile. Maybe this is something that could work. So it's going to be really interesting. This year's event is February 16th. It starts at 1 p.m. Pacific. And it's a live event, but it is virtual. And you can find out more information and sign up. If you scan that QR code that's on the screen, there's also the URL there. That's how you can find out more about who's coming. It's going to be really interesting. We have Kyle Weens at iFixit coming and actually going to talk about some of the different products that they've torn down and some of the things that they've learned by looking at the products of the people who are going to be in the audience. It's going to be interesting. Yeah.
I didn't put that together, but that's you're going to have, someone with a deep knowledge about the products right there in front of them, talking about all the.
And not everybody got rave
reviews. Yeah. Well, that's going to be cool. As I said, we have we're going to be promoting and sponsoring that, just like we did last year, because we at AMT really think that it's going to require a mindset shift in order to get to the future of manufacturing that we all know is just right in front of us. And we're only going to be able to do that through having these types of conversations. So I'm looking forward to that. Anna, how can people get a hold of you or learn more about Instrumental?
So I think we have a slide with another QR code on it. So if you want to learn a little bit more about Instrumental or actually speak to one of our solutions architects or one of our team members about your specific challenges These are folks that come from the industry, so we can help you with specific challenges. Or if you generally are interested in more information, you can scan that QR code and type in your info. Someone will get back to you the same day. If you want to reach out to me, I'm Anna, ANNA, at instrumental.com. Happy to be helpful if I can be as well.
Great. Well, Anna, it's been so interesting talking with you. It sounds like you're on the verge of some really exciting stuff. And I hope that whether it's instrumental or solutions like instrumental that get people sort of thinking in different ways and acting in different ways to see some big returns, that this really catches on. And at a minimum, I hope that everyone in the audience realizes that what we're talking about is not in the future. It's not just some buzzwordy thing that you read in the tech media, that this is actually something now that we probably
at this point, we've worked on enough programs. The probability that you own something that has been augmented in its process by instrumental is pretty darn high. So like, just keep that in mind. Like, it's real, it's there, and they're all doing. If you're in a company that's not doing that, all your competitors might be. And if it's, even if it's not instrumental, like, go out and look. There is stuff out there that can solve real problems in the kind of manufacturing technology ecosystem. You want to learn a little bit more about the different solutions, like Build Better will be a great place to do that. We have partners who are coming and going to be talking about, their solutions, and again, in a separate selling area, if you want to opt into that. Like, go start looking for stuff, because it's here, it's working, it's already impacting stuff you use.
Yes, exactly. So we'll leave it there. Anna, thanks a lot. Have a great rest of your week, and I'll see you at Build Better.
Awesome. Thanks, everybody.